Hi there. My name is Sean Logue. This is my Jing for week 10 of the Data Structures and Elementary Algorithms class at Manchester Community College, fall of 2018. Um, this week, what we were looking at is recursive searches. We looked up, or we had a lot of readings and videos about recursive things and how they basically call themselves. They're similar to like a for loop, I guess. Um, and I know one video explained it in terms of like factorials um, and how it calls itself. I don't think I actually did a recursive search right. um, what I did is there were a lot of instructions and it was difficult for me to sort them out, but I knew that I needed to get the file read in and then put into different lists. So I did that. And then I reread all the instructions and I realized that I needed to make that recursive. I didn't realize that in time to redo everything. Um, so uh, I thought that I would get wrong results because you said that this should be slower than the index search, I believe, and faster than the linear search. And I thought that was kind of interesting because I thought mine would be just super slow because I have, this is all code. I mean, I could probably clean it up. I could probably make it easier, but this is all code that uh, basically does the recursive search. And when I checked out my times, as you can see over here, the recursive search for this list that I'm using was in the middle, just like you predicted. Now, I only had a 100 element list, so the search times are really low. I didn't try it with higher numbers. Um, but I don't know, I found that really, really interesting. So it seems like it worked. Oops, let me get everything back up. So yeah, now I did make a couple different files, obviously, to do the index search, the linear search, and the recursive search, all with my same list that I was using. I made my list 100 random numbers out of 1,000, and I used the same numbers for every list. So I generated it and then used the same generated list for every one. And then basically I just read in the list and then I sorted out first into two divisions, like the lower half and then the higher half. And then I divide that between the lower and the higher and then the lower and the higher of the first one. I don't really know why I did it that way. Like I said, I just had a bit of time, not enough to complete the whole thing. So I was like, well, I know I need to do this, so I'll get this part done. And I didn't realize that I was actually kind of skipping the recursive part. But this reads it into different files, lowest, second, third, and last. And then it puts them all together again in the final list. And then I use the same functions I used. My understanding was that the recursive function, once it was sorted, then just relied on a linear search. So a recursive search, my impression of it was that it was pretty much just a sorted linear search. Now maybe that's not how it's supposed to be. Maybe there's a way to get a function to call itself, but I couldn't figure one out, at least off the top of my head, for sorting it either. Um, Now, obviously, I don't expect to get it off the top of my head, but like I said, I didn't have time to change all my code once I realized that that's not what I needed. So all this code should look really familiar, and then I just use a basic time thing. Um, so yeah, that's what I got for code this week. Let's see, I'm at 4 minutes, so I hope that works. Let's see. I know that one of the videos mentioned using stacks with recursive things, and I wasn't sure if maybe that was the way to do it. Um, in order to sort our list of numbers recursively, I didn't know if the search took place at the same time as the sorting, um, and I wasn't quite sure how to sort it. Just because if you were to go number by number, then how would you know which ones are in the bottom, the top, and the other two categories? I didn't fully understand how that applies to this. I understood what they were saying in terms of factorials, how you do 4 factorial times 4 minus 1, which would be 3 factorial. and then you call it again and you do 3 factorial. And I get that. I just didn't know how it applied to these lists. But like I said, I don't know if I screwed up, but I got the desired results. So anyway, this is Sean. This is my Jing. Hope this works.